live on YouTubia. So how you guys doing? How's everybody hanging in there? Any
Good.
like,
Seeing the light at the end of the tunnel with finals and stuff.
yeah, that's true. That is really true. I feel that, man. You know, we're really all in that boat together, man. We're all kind of, you know, professors and students alike are happy when the semester ends. I don't know whether most professors let on. It shouldn't be a mystery to anybody. But that is just a solid, great thing for everybody. Except for the part that there's a phase where you guys, not to play the I got it worse than you card, but from a timing perspective, because I would not trade, obviously. I mean, I did it, so I did my time being you. But the timing wise, there is a part where you like walk out of your last final and you're free. And then for me, there's like a week of work left, grading and, you know what I mean, pulling grades together and all that crap, which I don't like. Anyway, there are other things I dislike more. So, okay, so let's see. I want to just a reminder for the YouTube viewers that we've got live video and audio in real time on Discord, and you can track the whole lecture in real time on Discord. If you're just lurking and watching, hanging out on YouTube, you know, that's fine, totally fine. No, any news flashes from anybody? Anybody got like rocking like a quarantine beard going down, or I don't know I don't know, you know, what the common responses are to all of this. There's things, you know what I mean? I think the quarantine beard is a thing. I kind of already had it rocking, right? What do you guys do? What is the thing you do to mix it up?
To be fair, I was already growing out my beard. I just stopped keeping it trimmed nice.
Oh, there you go. Yeah. My son Brad said yesterday, he's like, I think your beard's getting like fuller, you know? And he goes, or maybe your face is just getting fatter. I'm like, those are probably both happening. So it's, I don't know. Anyway, the old offer stands if you want to just chat, or, you know, if you're struggling with the class and stuff, talk to me, you know what I mean, about schedule stuff. I'm still being flex on schedule and due dates and stuff. I don't know if I mentioned this today's Tuesday. April 30 that's a week from Thursday. Okay, April 30th is the official like last day of finals week, and that's the last day that I will take work. Okay, but I will take all other kinds of stuff kind of late, and but I will take it only up through the end of April 30th, because I gotta immediately turn around on that, and I've only got until like the 5th to get all the grading done, and, you know, for all 3 classes and get my grades submitted. Okay, but I will take kind of everything. Ordinarily there's kind of a strict rule that you don't go into finals week with assignments due, and I agree with that policy. You know, I don't agree with all policies, right? But I agree with that one because it kind of just respects finals week. You know, it's about, you know, getting ready to do well in your finals and things like that. And in light of everything going down with, you know what I mean, with the, whatever we call these things, I've lost track of all the terms. We'll just call it quarantining and self-isolating and, you know, economic shutdown and all the struggles. We're basically flexing on that. But ordinarily, I'm a big fan of, nope, the work is done by now, and that it's just about finals. Because if you're a professor like, I'm so nice, I let them do stuff through finals week, then what you really do is create like deadline pressures into finals week that actually hurt students in terms of preparing for the other finals and stuff. So I'm generally a big, you know, a supporter, you know, solid supporter of that policy, and I get why it's a thing. But anyway, in this case, everything's kind of open. Okay, and let me just say this too. If you're struggling with getting things done, there are a number of options that we can kind of crank on. And Ammon, we'll get to the question about prologue. So thanks for posting that. Anyway, if you are having a hard time just getting everything done, and again, as we've kind of talked about, everybody's reaction to this dynamic is different. For some of you, there's just kind of really no change. You know what I mean? Other than you really appreciate not having to get in and do the commute. That's all good. But for some of you, it's like really no change at all. And these are more of the introverted ones, and some of you a little more extroverted, a little more social, and sometimes it's just flat out disruptive on the emotions and the scheduling, just a bunch of dynamics. So if you're struggling in any of those ways, we can play certain tricks, okay? Like we can talk about an incomplete. We can talk about give you whatever the grade turns out to be, but talk to me individually about, maybe doing some stuff later on. Curtis is doing something like this in the compiler class, I think. At least I've heard. And I respect it, especially in the spirit in which it's, trying to be supportive of you guys. And so, that's one where we can always do something like, it's like a pseudo incomplete, where you kind of turn some work in later and we can do a grade change, so I can change grades after the fact. And, so in other words, we have, there are things that we can do to support you. Okay. All right, everybody got that? So, but if it's anything, if it's like turning stuff in, by the 30th, you don't really need to ask me about it per se. You just need to just do it. Just turn stuff in. If it's anything that goes kind of beyond that or a bigger sort of accommodation, just check in with me. We do need to talk to me about it, so I know what we're doing. Okay. All right, everybody cool? Where was that comment I saw rolling through? Was it from Erica? Where was that? I saw a comment fly through and I don't see it on Discord. Okay, would everybody please just jump on and sign the roll over on YouTube? Link is in Discord. If you wouldn't mind just signing the roll. And then seriously, I thought I saw something go by from Erica, and then now I don't see it. What the heck was that? Did I make that up? Oh, I can't hear you. Oh, boy, I hate that. Hang on a second. Okay, I'm gonna kill the voice and I'm gonna bring it on back. Okay, I'm going to bring it on back here. Shoot. You got, can somebody say something, see if I can hear you now?
Can you hear me now?
Yeah.
Hello.
I posted it to 3450.
Oh, okay. All right. Okay, I didn't know if that was related to this. Now what I need to do is something that I think is going to crash OBS. Okay. Darn it. Let me see something. Okay, I'm going to just take my chances. If I have to reboot, I reboot. Whatever. Okay, let's go live again here. And then blow that back up. All right. And I can still hear you guys now, right? Yep, got it. Oh, hey, okay, awesome. I just looked over on 3450. Nice. That's my unit right there. Okay. Alrighty. You guys have any other... Oh, yeah. Ammon, what's your question about Prologue Project?
I don't really know my extended family. Is it okay if I kind of just make up names of people?
Absolutely.
For the purpose of this project?
Absolutely. If you, in fact, Ammon, if you want to just use I provided data, if you want to use it, the struggle with as we talked about, if it's people then there's a bit more of a visceral reaction when you see the results. That's all. But if you want to do me or the royal family or just make stuff up, or a fictional, whatever, characters from Middle Earth. I don't really care. You know what I mean? Yeah, no problem at all. And literally, it's really all about relationships, right? So you could even do things like, I really don't even know. Anything where there's sort of a pedigree. You'll see things like doctoral pedigrees in the sense of, like who got their, who was whose advisor. And they're like legendary researchers, and they're like, these were their students, and then these were theirs. They do the same thing in like the coaching ranks, like which head coaches were formerly assistant coaches under other head coaches, that notion of pedigree. So it really doesn't matter. Anything that lends itself to relationships and connectivity and inference across the space. It literally doesn't even strictly have to be about family relationships per se. It could, you know what I mean? You'd have to kind of start with something different than, brother, sister, mother, father, etc. But okay, alrighty, cool. So here's what we're gonna do today. Today we are gonna we're doing the last kind of real lecture. I'm still figuring out exactly what I want to do for the second midterm / project. Oh, SRIs are out. I think I posted a message to everybody on the channel. But yeah, SRIs, you mind doing those? That would be fantastic. I think you get an email with a link. Pretty sure. And so if you guys would please do that, that would be great. The university does it and uses it. And then if you feel so inclined, there's also Rate My Professors if you want to jump out there. It's obviously less critical. If you are going to go out and Rate My Professors, and if you have a bone to pick with me, at least get the information correct. Anyway, there's one out there, right, from last semester, I think. You know what I mean? I mentioned it, right? You know the one. Anyway, it's like, there's no, I don't know, there's not really like a rebuttal option there, but it's like, seriously, I understand if you didn't like the class or didn't like me or had a, legitimate bone to pick, but at least get the facts straight, 1/3 of the classes were homework days because Dr. K does not like to teach. That's me. Guilty as charged. Okay. All right. We ready? Let me see. Where are we at here? Make sure I got my chat up. Yeah, Devin, thank you. Make sure and add that comment. No, don't do that. Okay, I have to tell you the one real quick story about SRIs. We called them something different at BYU. I don't know what they were, just student evals. But in this wireless class, no, what was it? Oh, we had a wireless class. It was a grad class, and we kind of made a pact that everybody was going to include the word wirelessness in their review somewhere. That was good. And then there was another one that was an empirical software engineering research class, and we decided that it would be funny if everybody in their reviews included the word imperial. And it was, these are like small classes, like 6 or 8 students, you know what I mean? The review's going to come in high. We're just there having a blast. And anyway, so those were kind of, we're a little large to pull something like that off, but all right. Yeah, be kind, man. Be kind. Alrighty, what else? Let's do this thing. Let's kind of roll through this, okay? Everybody cool? Let's do it. And then Thursday we'll talk about whatever we figure out for the midterm final action. Green light, go. Can I still hear you?
Yeah, good to go.
I'm all paranoid. I'm super paranoid because, it just cuts out and I can't hear you. I don't know why. Okay, thank you, green light, Ammon, for the green light. Okay, here's what we're doing. We're talking about a little bit more kind of background, history of programming. This is actually a really, really cool area. There's also, all of my books are in turmoil. Otherwise, I would have a couple to show to you right now. But there's a book that I really, really recommend that is called Engines of the Mind. by Joel Shurkin. Hang on a second. And I don't know if it's in print. My references go back, kind of old and deep here. It kind of seems to be, but anyway, this is Engines of the Mind. I don't like this cover at all. I really don't like this cover. To me, if any of you are like old classic rock aficionados, there was an album by Emerson, Lake and Palmer called Brain Salad Surgery. And this is a really horrible, I just think it's a horrible cover. But it's really a great book. So I just throw that out at you, okay? Engines of the Mind by Shurkin. There are a number of others that are just about, I have several feet of shelf space just on books, just with books about the history of the computing industry. There's another one, if you're more hardware, more affection for hardware, called The Soul of a New Machine by Tracy Kidder. That one won the Pulitzer Prize. And it really was about the creation of an early, I think they were making a mini computer at DEC or, Anyway, there's a lot of these kinds of, books out there. But the history of programming is really kind of what we're focused on. But, and then there's another book. Let me just throw one other at you that I think, there's one other book. And rather than pull it up on Amazon, I'm just going to pull up this is a picture of the cover. Let me see. Yeah, I'll just drag this. I'm just going to drag that over. It's got a bunch of other covers with it, but that's the cover of the copy that I had of Hackers. Now, this is not about security, okay? This is not about security hackers. This is about more like what we sometimes refer to as the hacker ethic, okay? This is hackers. Before there were security hackers, we referred to people who just sort of like got in and figured stuff out, and we called them hackers. Because do you know what you're doing? You're like, no, well, what are you gonna do? I'm just gonna hack it. I'm just gonna hack my way in. And it was a way of saying kind of the engineering ethic, where you're going to just go dive in and figure stuff out. All of those have really fascinating stories about the origins of programming and the earliest programming. Hackers talks about the Homebrew Computer Club, which is where Jobs and Wozniak were showing off the earliest Apple devices and the. Anyway, that's some of the early history of the personal computer industry. But anyway, those are just references if you're interested in that. And, summer reading, I think there's some really great stuff there to read. So Trevor asked, I've recommended a lot of books. Yes, I have, that I'd like to check out more. Do you have them in a sort of a formal list? No. But I am happy to try to put something like that together. So I am making a note to myself. The other thing is the books that I'm recommending, I have, like I said, several feet of shelf space. I'm putting this on my to-do list right there. I have several feet of shelf space dedicated to the history of the computing industry, and I'm not just going to be like, okay, here it is, here's the whole list. I'm really just trying to, when I bring up a book, it's because I've reread Engines of the Mind. I think I've read that like 3 times over the last 30 years. I've read Hackers twice, I think. So these are books that I'm willing to go back and just go, that was such a great read. Anyway, the other thing I recommend is there was a series, as far as the history of computing, there was a series that was broadcast on PBS. It was actually in the 90s while I was in my PhD program, and I just watched it when it was like on TV broadcast when that was a thing, and it was with Robert X. Cringely, and it was called Triumph of the Nerds. And okay, and there was originally a book by Cringely that was called, hang on, I'll have it here in a sec. But another one that it was called Accidental Empires. Yeah, so here's the book. This is the original book that Cringely wrote called Accidental Empires, okay? And the subtitle, which is so great, How the Boys of Silicon Valley Make Their Millions, Battle Foreign Competition, and Still Can't Get a Date, it's really a great book. And essentially, it's kind of about the flow and the evolution of the computer industry from its earliest roots. Cringely then did this thing called Triumph of the Nerds. There you go. 1996 documentary, 8.4 stars on IMDb. And you can also just watch it like on YouTube or in different places. But I recommend that one again. It's a little bit about programming, but it's also a lot about just the history of the modern computer industry. Okay, so I recommend that one a lot. This is Triumph of the Nerds, not to be confused with Revenge of the Nerds, which was this like really bad, it was trying to be a comedy. Anyway, unfortunately, some of you are familiar with it. Campy, nerd-based sex comedy. I can't recommend it. But I can recommend Cringely Triumph of the Nerds. Okay. All right. Okay. So those are just my off-the-cuff recommendations, and I'll try to pull together, the sweet spot, recommendation of books. Needless to say, I kind of read compulsively. I can't really shut it down, even if I wanted to, which I don't. So maybe those go together. Okay, let's do a little bit of history of programming languages. And I don't have with me here, but I think they're in my office at UVU. There was a series of books. Again, if this is of an interesting topic to you, there's a conference. It runs like every 10 years or something, and it's called The History of Programming Languages. Okay? Sorry, I'm just full of recommendations this morning. I want to just show you, let me see. No, I'm not coming up real quick, but they publish the proceedings in book form every year. Oh, here we go. This was, here, I'll just drop this over here. So I'll show you what I've got going on here on Amazon. I've got some, all right, this was the first one right here, History of Programming Languages. So 1981, and then this was the book they printed for the volume 2, 1995, so like 15 years later. And this is basically the proceedings of a conference that they run every like 10 to 20 years. And this is the kind of thing where, I can't look inside, okay. Anyway, this is the kind of thing. And there was, I think, a third one. I'm sure there's a third one as well. But, yeah, I'm not sure. Maybe not. Yeah. Anyway, but when you get inside of it, it's literally like, articles written by the creators of the languages. So all the languages we've been talking about, articles written, there's Alan Kay, with an article about Smalltalk, and and et cetera, et cetera, et cetera. So this is, again, and I have all those. I have all those on my shelf. Okay, all right, let's do the slide things. And I'm committed to doing this today, even if we have to move a little faster or whatever. I want to get through all these. It's like 66 slides, but a lot of it's repeat because we've already talked about it. Here's where we're going. Ready? I'm going green light. Don't stop me. All right. Here we go. Here's what we're going to talk about. The prehistory, early languages, and then kind of like, our languages for the class, right? Prolog, ML, Java. Here we go. Let's go all the way back to Babylon. Let's go 2,000 years BC. Let's go, what are we talking? 4,000 years ago. We've got cuneiform writing, right? We got clay tablets. And we also have astronomy, and we have math. Base 60. Base 60. That's just crazy. Like, where do you come up with that? And then there was this famous math tablet involving Pythagorean triplets, including like a typo. I don't know, right? I mean, I don't know who figures this stuff out. People. I don't know, but that's pretty tight. But anyway, so what they did was that they had two Babylonian digits. One represented 1 and the other one represented 10. And that when you bundled them together, you could make a number in base 60. And then when you did these numbers, you didn't have exponents. And the reader, maybe a little bit like how you don't have vowels in Hebrew, maybe, I'm not sure. But there were no exponents. And you had to kind of figure it out from context. I don't know. This to me just kind of makes me smile because I'm at the limit of my understanding of what this stuff is, by the way. So, but in that cuneiform, these cuneiform tablets, this was translated by Donald Knuth, who is a famous computer science professor from Stanford. He wrote a series of books called The Art of Computer Programming, maybe? The Art of something, but it was heavily algorithmically heavy, and an absolute classic by Knuth. Anyway, so The Art of Computer Programming. Thank you, Trevor. So a little program, a little computational procedure. A cistern, the length equals the height. A certain volume of dirt has been excavated. What is the width? You should multiply the length by. And if you're Donald Knuth, you translate this because Knuth is just one of those. If you're interested in the legendary figures in the field of computer science, Knuth is one of those, okay? Anyway, so you go way back, right? So essentially, they had a programming language. There were no variables, right? So what is that? Like functional? I don't know. So the very first programming language in the history of humankind was functional language. Right? There's no von Neumann architecture here. So numbers serve as a running example of the procedure. Doesn't that sound functional? Really, right? I mean, isn't when we do functional programming, if you're doing it right, which I think you've all been cured of, you're really just describing what the solution looks like if you do functional programming properly. And you're not trying to shoehorn and make it do it. You're just describing it. Anyway, yeah, so the point just being that programming was one of the first things people did with language. But it makes sense, right? I mean, I think that one of the things that I researched in my PhD program was just this idea that people have been solving problems since there have been people, right? So essentially, they're like human algorithmics, right? Independent of computers, independent of programs, independent of all that. People are solving problems. Well, how are they solving those problems? Well, it turns out, as we've kind of talked about with things like, addresses and whatever, that all the metaphors of programming that we've been talking about, the logical inference, functional, declarative versus imperative, these actually all exist in human algorithmics. These are extensions, which has interesting implications for Sapir-Whorf. But in human algorithmics, all of these approaches have all been used, right? Sometimes I tell you exactly what to do, and sometimes I just tell you what to do or give you an example of what to do and say, go do it, right? All these things we've talked about are kind of there. A few things that show up that are more unique. So now let's go with the story of Muhammad al-Khwarizmi. So now we go to Baghdad. We go back about 2,700, 2,800 years. And at this time, this is sort of the intellectual epicenter of the world at the time, okay? Scholarship, art, poetry. And here comes Muhammad al-Khwarizmi, who was a court mathematician, and he wrote 2 little books, okay? Kind of like Newton wrote this. Newton wrote a couple little books, you know. Al-Khwarizmi was one of these, you know, ancient, you know, Newton, Einstein kind of figure, okay? This was one that he wrote that was called, my Arabic is no bueno. Kita al-Jabr wal-Muqabala, I'm not sure, which means, which means the compendious book on calculation by completion and balancing. He included in that linear and quadratic equations were part of it, and balancing equations. Okay, so this book gets translated, gets spread through Europe, and it was the kind of de facto math text in Europe in Latin for 800 years. Imagine writing a textbook that has value. Well, for starters, the pace at which knowledge is growing has to be a lot slower than it is today, right? This idea doesn't even make any sense today. 800 years. Okay, we don't have the original anymore. Okay, they don't have the original, but there is a Latin translation, and I do actually possess some Latin skill. Algoritmi de numero indorum, which is translated al-Khwarizmi concerning the Hindu art of reckoning. We kind of lost the original, you know, but it's more like, you know, al-Khwarizmi's book, you know, those crazy Hindus, and it's about, you know, reckoning. And so again, you know, they use Hindu numerals, base 10, data structures, algorithms, right? And it was a huge influence on European math. But here's the cool thing. Did we even say it? Yeah. So then Euclid in 300 BC so basically backing up here, this is actually the algorithmi. That is actually where the term algorithms come from, okay? It comes from a Latinization of an Arabic name of al-Khwarizmi from 2,800 years ago. Okay, so this famous mathematician, and when it gets Latinized, it comes out as algorithmi, and then becomes anglicized as algorithms, okay? It's still pretty much the exact same in Italian today, algoritmo, algorithmi. But isn't that cool? That's kind of an interesting little bit of history there. Euclid shows up, and he does this, you know, algorithm for computing the GCD, the greatest common denominator. And then Alexander de Villede, and I don't know if this person is Italian, in which case that would be Villa, or Spanish, in which case it would be Villa, or Argentine, Villa. Canto de algoritmo, which were algorithms in Latin verse. We've lost our minds now. So, natural language, poetry plus math. Okay, that's cool. That's like weirdly cool. Okay, hang on. And, sorry, too many windows. Okay. Yep. Now we're going to fast forward to the first rumblings of modern computing. And when I say modern, I'm talking the 1800s, okay? Modern. So here comes Augusta Ada. She was the first-ish modern computer programmer, okay? And there was a language that was named after her called Ada. It was an object-oriented language used by the military, but there is a language called Ada. It was named after Augusta Ada. And so she is the daughter of Lord Byron. She is, it's the 1800s. Women are generally denied education. That was the culture, horrible. And then so she studied math with a private tutor. And anyway, she gets married. She becomes Lady Lovelace, has 3 children, and meets Charles Babbage. So we have the ladies doing the programming, and then famous Chucks. There have to be a Chuck shows up to do the good stuff. So Babbage is an English mathematician, okay? Yeah, I'm not sure, Devin. You have to give me some chapter and verse. I can't remember. She's widely credited with being the first programmer, but we'll see. And if you've got references, that's, let's pull them out. Obviously, we want to get the story straight. So what Babbage was doing was creating mechanical computers, okay? And in particular, he did the difference engine and the analytical engine. The difference engine was never completed, and the analytical engine was never built. Okay, so like famous Chucks, he didn't always finish what he started, right? And then Babbage in 1821, here's the quote, "I wish to God these calculations had been executed by steam." I don't even know what that means. But anyway, but they were programmable. You did have the ability to like configure them using certain things. So there was a processing unit. Okay, so Devin said the book says, our book says that the statement of her being the first programmer was an exaggeration because her paper was just an expansion on Babbage's work. Fair. But she was absolutely a collaborator. So processing unit that was called the mill, a memory that was called the store. It was programmable with punch cards, take that hollereth, and it included iteration, branching, pipelining, and other I/O devices, or a number of I/O mechanisms. So Devin said Babbage's work was on Bernoullian numbers. He wrote the algorithms. She debugged and fixed them. I don't know. I'm gonna give her some credit there. Obviously, she deserves some credit. As to whether she was I think there was a separate issue though in terms of like Babbage is the hardware guy and she's like the programmer. A little bit of that. I don't know. Anyway, so there was a paper written by Luigi Menabrea, published in 1843, and then Ada translated that paper and wrote explanatory notes for it. And anyway, there was a real programming language, so that's kind of cool. Yeah, so what Devin the Absurd said was it wouldn't have worked if she wasn't there. Keyboard drop. Okay. All right. Maybe, I don't know. Well, we got to dig in, man. We got to dig in. Engines of the Mind talks at length about Babbage and Ada Lovelace. So maybe I need to give another look there. I got to go dig that out of my stack of books. All right, so here's Ada Lovelace. This is the quote. "The bounds of arithmetic were, however, outstepped the moment the idea of applying the cards had occurred, and the analytical engine does not occupy common ground with mere calculating machines. In enabling, because there were calculating machines, in enabling mechanism to combine together general symbols, in successions of unlimited variety and extent." Now, doesn't that also start to bring to mind like a Turing machine? The generalizable computability, right? A string of symbols in unlimited variety and extent, right? A uniting link is established between the operations of matter and the abstract mental processes of the most abstract branch of mathematical science. And then Spotify. Boom. Pokemon Go. It's amazing, right? I mean, really, you think about, we're talking about the mid-1800s. Babbage makes that statement in 1820. We're only 200 years in the future. And I mean, it's amazing. It's amazing. Okay, let's keep going. Now we get to kind of more modern computing. Okay, so now we get into this story is amazing. So Konrad Zuse, who was in Berlin in 1936. That's not a great time to live in Berlin. He built a mechanical computer in his parents' living room. I don't know, they called it the Z1. Starting the tradition of naming, technology after yourself, culminating in Linux. I don't know, right? I also don't know, like, who are these parents that are like, yeah, Sonny, I don't know how old he was. Why don't you just build a mechanical computer in the living room? But rock and roll, man. Metal strips, pins, very different. Babbage had these wheels, and it was programmable with punched tapes. And you could do floating point with this thing. That's tight. Then he did the Z2, where he began experimenting with relays for the for an ALU, right, the arithmetic logic unit. Then he did the Z3, which was really the first electronic programmable digital computer, not commercially available. There's another man who talks about it. One of the books that talks about that sort of the race to the very first computing device, that, kind of who gets credit, right? Which usually goes to Eckert and Mauchly at Iowa State. Go Iowa, State of Iowa. I was a Hawkeye from the University of Iowa, not a Cyclone from Iowa State. But it's debatable, right? Who kind of gets credit? And obviously von Neumann is credited with kind of being the creator of that architecture and things like that. But anyway, so 1945, he's fleeing Berlin with his wife. So the first one is 1936. So now it's 9 years later. He's still doing that stuff. He's married. So I don't know how old he was when he was doing the thing originally. So he flees with his wife and the Z4. Okay. And then Zuse decided to, he started to work on this programming language that he called the Plankalkül, which I suppose if you're German probably rolls off the tongue like small talk. Prologue. If you're German, Plankalkül. I can't even pronounce it. I do have a little bit of German chops, but not many. And I have to share something with you now, which is this. I don't know if you can see that. I'll blow it up. In the category of wonderful words with no English equivalent, I bring you Kummerspeck, which is so appropriate to us like right now, okay? Excess weight gained from emotional overeating, literally grief bacon. So as far as I'm concerned, Plankalkül, which I don't even know like strictly what the German means. Yeah, I don't know, Ben. Is somebody here got some German chops? Because I don't even know how to break it down. But they should have called it Kummerspeck. Grief bacon. It's delish. You're like, how's your grief bacon? Delish. Okay. I don't know. Anybody really seriously? Does anybody have any German chops? Either to how you say it or, anything. Something about plan calculus. Oh well, that kind of makes sense. Plan calcul. Boom. Plan calculus. All right, that kind of works. It's probably on my next slide, and I just forgot. Anyway. So, all right, plan calculus. So. He did this. So here's the things that show up. This guy, I don't know anything about this guy, this Zuse, just like a casualty of the war, but what a brilliant guy, apparently. So this language includes assignments, expressions, subscript, constructed types, base types, integers, reals, arrays, conditional execution, loop subroutines. Amazing. And then a bunch of programs, sorting, graphs, numeric algorithms, syntax, right? Syntax analysis. Well, he's trying to maybe write that first compiler, write that first chess program. That's remarkable. That's like truly remarkable. And you're like, what is the story? So here comes a little bit of, this is just kind of the notation. I wonder why that didn't catch on. I don't know. But I mean, right? There's nothing about modern programming notation that's like, oh, that's how this had to end up. There's nothing inevitable about that at all. But that's some variable V0 subscripted with Z1 and it, having 1 incremented to it. So that's your notation. I don't know. So this is the thing. This is the thing. It looks influential, but it was not. And this is also one of the weird things about having influence, being the influencer. There's so much luck involved. I mean, really, you got to be brilliant. You've got to do the thing, but you know what I'm saying? What if, remember the story about Alan Kay and the other grad student who are like, unrolling what they thought was Simula. No, they thought it was Simula. What did they think it was? They thought it was Algol, right? And it was Simula. If he doesn't just stumble into that experience, does he go make small talk later? There's just so many little moments, little pivots that if they don't happen. So this guy does all that work, all that brilliance, and then it doesn't get published till 1972. By which point, the core ideas were kind of already out there. So, and then essentially most of what he did was then reinvented by other people. Fascinating. Fascinating. Okay, now here comes Fortran, which was the workhorse. Fortran was the workhorse of programming for a long time. And I'm even considering COBOL and then the Algol derivatives, which turned into Pascal, which frankly turned into C. But Fortran, right? So, and we kind of talked we talked more about this like in 2810, but it's hard to appreciate just how tedious programming was back then. Super, super labor intensive, right? So here comes Grace Hopper, who was the inventor of COBOL. In the early days of programming languages, the most frequent phrase we heard was that the only way to program a computer was in octal. Meaning, and that was my first assembly language that I ever touched was in octal, right, which is base 8. And then what that means is that every octal digit turns into 3 bits, right? And that was literally the first assembly I ever touched was using that kind of a system. And when we're talking about programming in octal, it would be a little bit like, programming in machine code. Today we would probably be in hex, but it would be just like you're just writing a bunch of stuff, you're doing the machine code, you convert it to hex, and you're just entering those hex digits into memory. Essentially, it's like the machine code programming that we do in 2810. And what Grace Hopper is saying is, that people would say that was the only way to program a computer, right? And then, okay, of course, a few years later, a few people admitted that maybe you could use assembly language. Yeah, maybe. You think? She says, I have here a copy of the manual for Mark I. I think most of you would be totally flabbergasted if you were faced with programming a computer using a Mark I manual. All it gives you are the codes, the machine codes. From there on, you're on your own to write a program. We were not programmers in those days. The word had not yet come over from England. We were coders. That is where coding, as I'm coding, that's where it comes from. Machine code. Coding. And that's why we're coders. Boom. And then when you talk about, and then where the term source code comes from, right? There's machine code, which is code. The codes, okay, is machine code. Then if I could get this program like assembly and assemble it into machine code, well, that's still the codes, but this is my source for those codes. Hence, source code. Boom. And then, of course, high-level languages with a compiler or an interpreter, and we still call it source code, meaning We know it's not the actual low-level thing that's running. It's not the Java bytecode. It's not the machine code, right? It's not the object code. It is the source code. It's the thing that I'm looking at that I'm driving from. So that's where that comes from as a term. And then what's kind of interesting is it comes full circle when you can tell when somebody isn't a programmer and doesn't really understand the vernacular, when they'll say things. I get into this sometimes doing code reviews, right? On like legal cases, whatever. And they'll say, you'll hear people talk about, code has to be singular, right? You have to say, can I look at the code? Can I see your code? Where's the source code? And if somebody says, can I see the codes? You're like, I don't know. Do you have the decoder ring? Because I don't think I can show you the codes unless you have a decoder ring. So anyway, that's one of those really weird vernacular, because originally it was codes. And then it turns into code, and then it stays code. And anyway, that's how you can detect somebody. In the same way that I can detect a sales call if they ask, is Charles Nuts in there? Okay, you know what I mean? It's a way of detecting whether they actually have familiarity or not. Okay, so these were things that they wanted. Floating point, right? Relative addressing, right? This part, and this is kind of 2810, right? Every time you're constantly having to adjust the offsets and things, right? For absolute addresses. Something easier than octal. And then early on, we had assembly language, okay? Mauchly did this. I don't know if that's Mauchly or Mauchly. I don't know how he said the name. But he was one of the early, again, it was Eckert and Mauchly at Iowa State. But that was 1949. Grace Hopper did several iterations. John Backus of BNF, the B in BNF, also, right? Anyway, but people began to see at some point that saving programmer time was actually valuable. And this is an interesting transition that you have to kind of get your head around. Back in those days, you've got a machine, it's 1950, and you have a machine, and the machine is worth $1 million, right? And operating it is expensive, and just amortized cost of this thing, $1 million. What's a programmer cost in 1950? $5,000 a year? Okay, what's the most expensive thing? Hint, not the programmer. It's the hardware. Therefore, the idea of programmers having to do a bunch of stuff, to write programs was not like a weird idea, because you're like, well, we could write an assembler, and you could write your code in assembly, and then this assembler, and you're like, who's running the assembler? Well, it would run on the computer. Okay, right. So we're going to burn computing cycles on this computer, this $1 million computer. We're going to burn its precious cycles so we can save that programmer, 40 hours. What's the cost of that 40 hours? Right? 1 week? What is it? Really, like literally, if the guy's making like $5,000 a year, what is that, $500? So the cost of making this guy code it is $500. The cost of the computer running to compile it, to assemble it, is, not insignificant. Interesting, right? And then you swing it all the way. That's where the pendulum was. $1 million computers with $5,000 programmers. Now let's flip it the whole way. And now we have, if you got a fully loaded laptop of your dreams and an external monitor, maybe you're $5,000, right? So now the hardware is $5,000 plus the internet and the rest of the world resources all kind of at your fingertips. And what's the what's the burden cost of a programmer today? By burden cost, I mean the other stuff, right? And $100,000 probably average right now, right? So that's kind of come completely, right? So now the notion of having all kinds of computationally intensive helps to make it easier for you to code at $100,000 a year makes perfect sense. Taking this very expensive machine and making it do a bunch of work to save the $5,000 a year programmer didn't really make sense. Okay. Ooh, yeah. Okay, so Emin, work refuses to buy a second or third monitor for their most productive developers. $400 expense. Oh man, don't get me started. That is called penny wise and pound foolish. That is what that is called, Emin. You've got a literally at $100,000 a year burdened cost for that individual. They want a monitor. They want two monitors. Let's say they only game on the monitor. Let's say they only use the monitor for gaming on their lunch hour. Buy them the monitor. I mean, unless you're a startup and you're just totally strapped. That's a possible scenario. But if you're operating in any kind of normal ranges, that $400 for an extra monitor, $1,000 for an extra monitor, in the noise. In the noise. That is just dumb. Okay, I have more stories. Don't have time for them today. Okay, so that kind of was the background that kind of led to the creation of Fortran, which was the first popular high-level language. John Backus, again, of BNF, of Backus Now Reform, at IBM was the leader. They called it IBM Mathematical Formula Translating System Fortran. Let me see, took a couple years. Yeah, it was supposed to get rid of coding errors. It was very tied to the hardware. Okay, the notion of separate compilation came later. That wasn't part of the original thing. Okay, so keep in mind that this was very tied to the IBM 704. Compiling big programs, and a big program was like, a few hundred lines of code. This is what this means. The compile time approached. This means the mean time to failure. And by the 704, that means for that particular machine, for that 704. In other words, back in those days, they have this, they still have it, I think. They call it a mean time to failure, which means the average time that the system is up and running before it crashes and has to be restarted. That was the metric back then, okay? And what's our year? Do we have the year? Yeah, we're in the 50s. The computers weren't reliable. So you literally measured, like, I have a better computer because it has a higher mean time to failure. You have to reboot it less often, okay? And then what happens is, when you get into a situation where the time to compile, like, this is how long this computer's going to run before it crashes. And then also, this is about how long it's going to have to run to do the compile. You see the problem? So you needed separate compilation. So check it out. Why does the programming language landscape evolve? There's so many funky dynamics. In this case, I needed to do a separate compilation so I could compile a small chunk, save it away, and then do another small chunk, save it away, because the computer was going to crash soon. And if I could do the compile, And by the way, I actually had an environment that was almost exactly like this in the early days of computing, writing programs that got big, where literally the compiler would die or somebody would die, and I actually did separate compilation to sort of get it under the window for when the thing was going to fail. Anyway, so here we come, C.A.R. Hoare, who's a famous, kind of legendary writer, researcher in software engineering. So in 1982, I don't know what the language of the year 2000 will look like, but I know it will be called Fortran. A swing and a miss. Yeah. Anyway, crazy. Let me see. So Ammon's saying, oh man, I buy the hardware I know will make me more productive. Let's talk more about that, Ammon, okay? Anyway, Fortran had a huge influence, okay? There was a lot of pioneering, scanning, parsing, a bunch of stuff. Registry allocation, code generation, optimization. And really Fortran was kind of the granddaddy of them all. John Backus contributed a bunch of stuff. Fortran, Algol, BNF, right? FP was this functional language that he made. And then here's Backus who said this: My point is this: while it was perhaps natural and inevitable that languages like Fortran and its successors should have developed out of the concept of the von Neumann computer, as they did, the fact that such languages have dominated our thinking for 20 years is unfortunate. This is about paradigm. You see it? This is about how we think. It's unfortunate because their long-standing familiarity will make it hard for us to understand and adopt new programming styles, which one day will offer far greater intellectual and computation power. I'm most concerned about the intellectual in this instance, right? And remember, the concept of like, blah, blah, ML, it's all von Neumann underneath, it's all registers and memory locations. Sure, but that ignores the fact that because of the way the language is built, it changes the way you think when you program. That's the save right there, okay? That's the win. And Bacchus is right, and it did take quite a while, but on the other hand, you got to get something established and stable and functional. You know, we need C, we need Unix, we need some stable things. And then it's like, okay, we're ready for C++, we're ready for Java, we're ready for, what are we ready for? Python, I don't know. We're ready for stuff. Okay. Now comes Lisp, which was one of the kind of the grand parental functional programming languages, okay? Presented in 1956 at this conference on artificial intelligence. Isn't it amazing that we were talking, by we I mean they, I wasn't even alive yet. They were talking about artificial intelligence, and it was the 50s. Now, we actually kind of stopped using that term for the most part. We prefer words like machine learning. AI just kind of conjures up, the image of like robots are going to kill us, right? Then we're going to need robot insurance. You know what I'm saying? So, what else? These guys demonstrated, and I don't know. Okay, I don't know those folks. I don't know if Shaw is Mary Shaw. Anyway, Logic Theorist, a reasoning program written in IPL, and it had things like linked lists, which was kind of a big thing. McCarthy, who was one of the early, folks at the AI conference that they launched, he wanted a language for AI, right? He didn't like IPL. So they developed FLPL, Fortran list processing, right? And what else? McCarthy had a wish list, recursion, higher order functions like map, garbage collection, conditional expressions. So the FLPL, despite being unpronounceable, was no bueno. But Lisp, which was short for list processing, McCarthy writes this paper showing a simple Lisp interpreter in Lisp and this function called eval. And it was kind of this, this kind of abstract syntax tree. Anyway, we don't really go into Lisp, but it's essentially, it's one of the earliest, maybe, I don't know, the earliest, not the earliest, but one of the earliest functional programming languages. So anyway, what else? What else is kind of relevant here? Oh, everybody was still trying to bridge Lisp into Fortran, and it never really worked, never really caught on. So, and then the notion of programs and data having the same syntax, right? Like Prolog, similar. What else? Bunch of dialects. Today there's Common Lisp, and then there's Scheme, which is kind of a smaller and simpler dialect. I don't have much Scheme literacy. I have written programs in Lisp. It's been a long time. Anyway, this is a funky point. The second oldest general purpose programming language still in use. First one, I think, would be Fortran. Third one has to be COBOL. I mean, COBOL was the 50s, and that was Grace Hopper. So I don't know if we're going to talk about COBOL. COBOL was going to be the language that allowed us to just talk to the computer in English. It worked out really, really well. Let's see, what else? Algol borrowed from Lisp. garbage collection. It influenced all the modern functional languages like ML. No COBOL. Oh, come on. We're shorting Grace Hopper. That is not good. I mean, we quoted her, but this needs COBOL in there. Sorry, COBOL. All right, and then here, by the way, Algol, we're going to skip over small talk, but Algol, it's interesting because, it's late 50s and language, isn't that weird to think about? I'm not born yet and languages are proliferating. That's a little crazy. And then we've got, languages, right? Plankel, cool. Algol was trying to be the universal language. Okay? And an international committee, that's going to end well. So then comes a bunch of Algols, and suddenly they start to look like versions of Windows, back when Windows was named after years. 3 major designs: Algol 58, Algol 60, Algol 68, increasingly large international committees. There's just, I don't know why my little scare exclamation points are there. I just think that maintaining languages with committees, I get. Creating languages by committee feels scary to me. Anyway, but here's the interesting thing. Algol, when you think of every sort of usable modern imperative or object-oriented programming language and functional, really, they all owe this massive pedigree back to Algol. Okay, certainly, imperative languages like Pascal and C, absolutely. And then the object-oriented languages, the object-oriented wrapper was a thing, right? The object-oriented wrapper was a thing, but inside always in those methods, that data, right? Those were always predominantly imperative in their flavor. So things that began to happen: compound statements, the ability to say, and now comes, if blah, 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 then begin all of this and then end. That was new. Usually, back then you have to call a subroutine or do other things, right? Free format lexical structure, instead of it has to be in these columns. And then interestingly and weirdly, but cool-ishly, one of the things that staggered me when I started to learn Python was, wait, no begin statements, no end statements, no opening brackets, no closing squiggly bracket, indentation. Okay, funk. That's a throwback. But it's almost like, now we overshot on that one. Really, the indentation wasn't bad, but with Fortran, you literally had things like column 5 has to mean this. Column 7, means this, stuff like that. So it was almost like a throwback, no, let's just do indentation. It's visually great. You can see immediately. You do it anyway. Your eye ignores the squiggly brackets when you actually use them, right? So anyway, it used BNF to define it. What else? Local variables with a block scope, right? Now that kind of gets you to the activation record, stuff like that. Static typing, nested if then else's, call by value, and call by name. Call by name. Nothing but trouble on that one. Recursive subroutines. There's some serious crap in Algol. And I'm just, still running around in, it's the 60s when this is sort of emerging. And I'm still off, doing whatever we did in the 60s. Free range parenting is what we did in the 60s. We just took off. So let me see. Do I want to talk about this one? Yeah. This one is interesting because it brings up Dijkstra. You may know Dijkstra from the dining philosopher's problem, the Dijkstra's algorithm. Dijkstra is very, very famous, computer science theorist, and his name is attached to a number of kind of critical theoretical things. And they show up a lot in operating systems and things like that. But in the early programming languages, there was this. Think about what happens in assembly, right? You use labels and then you reference the label, right? You can jump to the label or branch to the label on some condition. Well, back in those days, they would have go-tos, right? Go to 27. This is like Basic. Basic did this. You jump to a number, and the number was the line of your program, the number of the line, and you could assign numbers. So you could assign numbers like, well, this is 100, 200, and then it's not like assembly where it's every instruction in memory. You know what I mean? Has a contiguous number, or contiguous spots in memory have sequential numbers. In like Basic, you could just tell what the number was as long as they went from small to large, and then you just go to those labels, right? And so Algol, brought in, things like an if statement, right? While statements, that kind of things, right? Well, but back in the day, it was still very common for the old school programmers, who are all dead now, probably literally dead, to still kind of just default back to go-tos. And they would write this horrible spaghetti code, because you just jump here, jump back out, and Dijkstra wrote a letter to the editor. I believe it was in the communications of the ACM. This is a famous pub, but it was actually a letter to the editor entitled "Go-To Statement Considered Harmful." And weirdly, this is 1968. Weirdly, he proposed lose it entirely. And this is about the time that structured programming began to become a thing. And modularization is about to show up. And Parnas is about to show up and talk about information hiding. Okay? This evolution of programming was all kind of happening. But this is one of those moments where everything was kind of poised, and then this luminary, Dijkstra, just gives a little push with a provocative title, "Go-To Statement Considered Harmful." And now that sticks in the memory, and really the decline of go-tos started right then. It was already kind of moving. Dijkstra gave it a shove. Later on, we found back when C and C++, I don't know, I think those might have been the first ones to actually employ this, right? You get yourself just nested like crazy in a deep, deep whatever. And what did we bring up? Break. Now, break is at least not label oriented. You're not saying jump to there. You are saying break out of this thing I'm in, but it really is a go-to. And by the way, one last thing about this. Back in the day, this ethic at some point was so strong that you didn't want to have like multiple entrances into a routine and multiple exits out of the routine. Right, yeah, so Ammon said label statements are powerful, but definitely an anti-pattern in most cases. Yes. But back in those days, you'd have this chunk of code, and you'd jump into it at different locations, depending upon where you came from, and jump out of it at different locations. So it was code reuse, but of a most pernicious variety. And we kind of got rid of the whole jumping into a routine at different places. Typically, we make a call and we start from the top. But that ethic was so strong when I first started as an engineer that you would basically navigate your way around, save like an error code or do whatever you did, and then you would have like a single return at the bottom. And you would kind of like make your way to that one return. The ethic was so strong. One point of entry, one way to get out. And then we kind of relaxed that a little bit, and we kind of said, that's a little dumb. Like right now, I know I want to return error 73. I know it right now. So making me save 73, put it in a variable, skip out here, set a bunch of conditions. If not error already, then do this stuff, just to make my way down to the bottom to then do that error 73 as my return. And it became more kind of conventional to say, as soon as I know I need to kick out of this routine with an error or the answer, I'll just put my return. Wherever I'm done and I know, I'll put a return. That became kind of conventional because it really was, but it was well managed, I guess. It was kind of a reaction. Thank you, Ammon. Is that a thing? That's not out of your code, is it? From like your company? You suggesting somebody get fired? Okay. Anyway, but do you see, this is some really fascinating history. It's very, very fascinating. So again, structured programming shows up. C++ has it, et cetera, et cetera. But ALGOL really triggered it. Other issues, let me see. What else do I want to say? Because we're really kind of out of time. Nothing, I don't want to talk about that. I don't want to talk about that. Oh, ALGOL never caught on. Why? They neglected I/O. What could go wrong? It was kind of complicated. Pass by name parameters. No, that was never a good idea. It was an idea. No corporate sponsor. Anyway, we already talked about Smalltalk and Simula, right? We had a good discussion. So here's where we wrap up. We did Prolog. We had a good talk about Prolog. We talked about the evolution. We talked about ML, didn't we? The actual language. I don't know if we actually talked about the language ML, but it goes back to 1974, and we've done a lot with ML. The draft standard. Let's see. Standard ML. That's the one we used. Lazy ML, Camel, OCaml, F#, etc. We talked a lot about Java, and this is just interesting in the sense of, there was this language called B, right? And you know that C was a follow-on to B, right? But B actually, anyway, this is kind of a little bit of the history of, going the other way. ALGOL gives rise to CPL, which gives rise to BCPL, which gives rise to B. And then, anyway, certain things, all the way back then we had, plus equals and things like that. Cool syntactic sugar. Then B gives rise to C. C gives rise to C++, which gives rise to Java. There's that pedigree. And then we talked already about Java. And here's what I want to just say. These are the language pioneers that have won the Turing Award. There have been a lot of Turing Awards given to language people. Okay? And this is the other interesting thing. Before it was perfectly obvious, they had to kind of go, hey, what about this? That's kind of cool. And I think this is the last slide. Is the evolution of languages nearly done? No. The short answer is no. The slightly longer answer is hell no. No. Not even close. And whenever the von Neumann architecture gives rise to whatever the next thing is, everything is going to be an upheaval. I don't know if that'll be quantum computing or what it'll be. But if that ever pivots and goes away, everything is going to change, and you're all going to feel super stupid like I do all the time. You are probably going to look as stupid as I do. But no, you know what I mean? You're smart right now. You're smarter than me in most respects right now. And then, but in another 40 years, 30, 40 years when you're my age, the new whippersnappers are going to be coming up, and it'll be a different world, and you'll be speaking with an accent and feeling kind of dumb. That is really the punchline, is it is never going to change. One last story, and I know we're out of time. I mentioned one of probably my very favorite professor, no, definitely, in my undergrad was Evan Ivey. It was his group at Bell Labs that created Unix and the C programming language, and he was really kind of like, he was a legend. He was really a legend, and he was also just the sweetest guy. He just passed away this semester. I went to his funeral. But Ivy was talking, I may have mentioned this once, but it was just class, and he was talking about, it was just like, so, in 20 years or, whenever, and you're programming in, and he pauses and he goes, well, I don't know what it'll be. It was kind of like a variant of Bacchus's statement. He goes, I don't know what it'll be, but it won't be C. But whatever it is you're programming in. And I remember sitting there because C was like the thing. And I didn't have enough real history to kind of get the fact that C had shown up and it was going to go away, And I remember just being struck. I don't know how old I was, 25 or something. But I remember 26. I remember being stunned by this idea that wait, this is this legend. He doesn't know what I'm going to be doing in 20 years. He doesn't know what the language is going to be, and it won't be C. There was an early kind of a spark for me to just think about the fact that all this stuff's going to be changing, evolving, moving, shifting. And I just want you to get ready for the fact that you're never going to be more competent, really educationally, than you'll be, within 5 years after you finish your degree. You'll peak within 5 years, by which I mean everything's going to keep changing and shifting out from underneath you. And increasingly, there's going to be new stuff show up. And it will be stuff you won't have ever heard of or seen before. And if you don't figure it out, you're going to be obsolete, and the younger kid's going to come and eat your lunch. Okay, this is why excess hand-holding in your education, especially at the senior level, is bad for you, considered harmful. Okay, because the world you're going to go out into and live in and occupy for the rest of your careers is a world of constant learning and, frankly, constant incompetence. And I don't mean that in a bad way. I just mean that in a good way. It's the orders of ignorance, right? The reason I teach you the orders of ignorance is so that you get comfortable with this idea that being ignorant, meaning not knowing things, is the natural state of every learner. Okay? That is the natural state of a learner, is ignorance. Because you're moving constantly to the threshold of the things you don't know instead of nestling back with the things you do know and being comfortable there. You will be obsoleted. Your career will be stunted if that's your approach. So you got to be leaning forward in the skis and always just kind of like, what's the new thing? And learning forever. Learning constantly until you're out of the industry or dead or something. Okay? So that's kind of the moral of the story here. The programming language landscape will constantly evolve. And I'm learning Python now, right? How long is that going to serve me? I don't know. How many years do I have left? Period. I'm fighting that one, right? Anyway, you know what I'm saying? And the answer is I don't care. I don't care. And after that, it'll be something else. After that, it'll be something else. And after that, I'm probably kicking the bucket. I don't know. So, anyway, all right. That's the end of content for this class. I'm glad we figured out how to live stream into Discord. That was big. Anyway, also just keep in mind, I can hang around, Nathaniel, a couple questions about homework. I'll kill the YouTube broadcast, but I'm happy to just kind of hang around for a few minutes. But anyway, we'll talk on Thursday about the final. We won't take the whole time. And I can just kind of, in fact, Thursday will be kind of just, optional. It'll be broadcast. You can look at it later if you want, but I want to just kind of just walk through. I don't think it'll take long. So, all right. Hey, it's been good. Yes, and Ammon, I'm going to put up the review material. Yeah, I'm gonna update the study guide, which I still need to do, so that you have the latest and greatest stuff to look at for the last exam. Okay, friends, I'm gonna truncate now on. Well, I'm gonna hang out. I'm still gonna stay on Discord, but I'm gonna go truncate the YouTube broadcast.